Okay, for the simple harmonic in the real world. So let's take, I've got a fan here, okay? And we can take we can figure out, and it's going to be a slow moving fan. So that's the point that I'm starting with. And I'm going to go ahead and say that that point is starting at 0. So my phase angle is going to equal 0. Because I can do that. I can start my phase angle anywhere I want. I take a ruler and I measure this distance. And since this is a small desktop fan, or it could be one of the little fans that you got for staying cool outside, and that A is going to be the R, which we're going to say in this case is 0.25 meters. And we're going to calculate, or we're going to measure the time that it takes to go around. So the period, I can measure 10 and divide by 10. I can find the period for 1. And let's say it takes 0.5 seconds for that to move around. My equation of motion as a function of time is going to be A cosine, and we have the omega t plus v, but omega is equal to 2 pi times the frequency, which is equal to 2 pi divided by the period. So if I did this, there's my period. I got 2 pi divided by 0.5 seconds is going to equal, I've got 4 pi here. And I could write that out as a number, or I can leave it in 4 pi. But what I'm expecting to see in your PDF is as follows. I've got my 0.25 meters, my cosine, my 4 pi times t. We said my phase angle is 0. This is what I am looking for in your PDF for your real world example. Now, if you take something that's out there and maybe you can't, for whatever reason, like you're using say a pasture windmill, give me a reasonable A and tell me that you made the assumption that a blade on the pasture windmill is, 1 meter, and I will accept that. But I need something reasonable that goes with your particular system. You can use video to help determine the period. You can use counting back and forth if you're using a pendulum or spring. Those are all the things that are there. But you're going to need to figure out whatever your amplitude is. You've got to figure out your period, and then you're plugging it into the equation, but you're leaving it as a function of time. So that's been a common question for the simple harmonic in the real world. So McKenna and Lynn, did that answer your question?
So for the amplitude, are we looking at like just the length or is it like the actual wave? So like if it was a swing instead of like a circular motion, would we be measuring?
Well, if it's the swing, you're measuring this distance.
Okay.
It's not the length. You're measuring this distance because it's the deviation from that center if you're doing for a swing.
Okay, thank you.
Because think of it this way. If I had a pin at the bottom of the swing, I'm going to create it like this in the sand. And that's going to be my amplitude. Okay?
If we've already submitted, but we didn't put exact measurements, can
You
we?
can resubmit.
Yeah, I was like, can we resubmit?
And you can either, and if Blackboard doesn't let you, send it to me as a message or as an email.
Okay, okay. Yeah, because it says 0 attempts left.
Yeah, that I'm okay with. Yeah,